Welcome to The Explainer. Today we're talking about something pretty big. It's the moment that AI video, finally found its voice. We're going to look at a new model that doesn't just make silent movies. Nope, it creates sight and sound together, just like in the real world.
So we've all been blown away by the text-to-video AI stuff, right? You type in a crazy prompt, like a corgi conducting a symphony orchestra on Mars, and boom, you get this stunningly realistic video clip. The quality of the visuals, it's just gotten incredible.
But here's the thing. There's always been this catch. All these amazing videos, they've been totally silent. It's a little eerie, Like watching these beautiful little films without any dialogue, no sound effects, none of the background noise that makes a scene feel, well, real.
Okay, let's get into this, because it's not as simple as just slapping a soundtrack on top of the video afterwards. This whole silence problem in AI video has been a really tough nut to crack for a reason.
See, the old way of doing things was what we call decoupled. You'd have one AI generate the video, and then a totally separate AI would come in and try to, guess the right sounds to go with it. But that's a flawed approach from the get-go. I mean, think about it. In reality, a car driving by causes a sound. A person speaking causes their lips to move in a certain way. They're not two separate events, they're completely connected. The new unified approach gets this. It generates both at the exact same time.
And that, right there, brings us to LTX-2. This is a brand new open source model that was literally built from the ground up to generate sight and sound together, all in one seamless process.
The key thing to remember here is that LTX-2 isn't just tacking on a soundtrack as an afterthought. You give it a single text prompt and it creates the whole thing, a complete, perfectly synchronized audiovisual experience. The pictures influence the sound, and the sound influences the pictures, right from the very start.
So how in the world does it actually pull this off? Well, the secret is in its really clever architecture. It's designed to handle the very different ways that video and audio work, and it does it in a super efficient way.
Okay, so at the very heart of LTX-2, you've got these two separate pathways, or streams. One is totally dedicated to video, and the other one is dedicated to audio. This is the core idea of what's called its asymmetric dual-stream architecture.
Now, the really brilliant part is the asymmetry. Look, video is just incredibly heavy, data-wise. So the model throws a powerful 14 billion parameter stream at it. You can think of parameters as all the little knobs the AI can turn to learn things. Audio, on the other hand, is a bit less complex, so it gets a more focused 5 billion parameter stream. It's just a really smart way to put the processing power right where it's needed most.
But wait a second. If they're in separate streams, that brings up a huge question, right? How did the cinematographer and the sound engineer, so to speak, talk to each other? How do they make sure the dialogue actually matches the lips and the crash sound happens exactly when the car hits the wall?
And the answer is this really cool mechanism called cross-attention. You can see it right here. The model's focus is locked directly onto the speaker's mouth. The video stream is literally watching these key visual cues to make sure the audio it generates is perfectly, and I mean perfectly, synchronized.
And it's not just for people talking. Check this out. In this example, as the car moves across the screen, you can see the model's attention is following it. That's what lets it generate the sound of the engine getting louder as the car gets closer, a level of realism that was basically impossible with those old, separate methods.
LTX-2 has another trick up its sleeve for when you give it really complex prompts. It uses something called thinking tokens. The best way to think about this is like the AI is taking a moment to kind of jot down some notes for itself, to make sure it fully understands what you're asking for before it even starts generating. And that leads to way better, more accurate results.
So, yeah, the architecture is pretty slick, but how does it actually perform out in the wild? I mean, a great design is only great if it delivers real-world results, both in speed and in quality. So, let's talk numbers. The performance jump here is, well, it's staggering. LTX-2 is about 18 times faster than other comparable models. This table really drives that point home. Okay, so when they tested this on a super powerful H100 GPU, that's the high-end stuff for AI, a similar video-only model took over 22 seconds for each step of generation. LTX-2, while creating both audio and video, did that same step in just 1.22 seconds. That is an 18-fold speed increase. It's just wild.
And it's not just faster. It can go for longer. At 20 seconds, LTX-2 can generate clips that are longer than other top open-source models, and it even beats some of the big proprietary ones from companies like Google. This longer runtime just makes it so much more useful for, actual storytelling.
So this technology is clearly incredibly powerful, and it's improving at a shocking rate. But what does a world with this tech actually look like? This brings us to some amazing opportunities, but also some very, very serious challenges.
On one side, the promise is huge. This could completely change the game for independent filmmakers, help create amazing educational content in any language, or produce rich media for the visually impaired. But the other side, the peril, is just as real. The potential for creating extremely realistic, deceptive misinformation is a massive concern. And so is the risk that these models will just amplify the biases that are already baked into all the data they're trained on.
And all of that leaves us with this final, really critical question. LTX-2 is a giant leap forward in making AI content feel real. And as this tech keeps getting better, that line between what's synthetic and what's authentic is just going to get blurrier and blurrier. The real challenge for all of us is going to be figuring out how to navigate a world where seeing and now hearing might not be believing anymore.